Topic number 4-2, sums and products. Write the expression which sum to the first given expression and yield the product of the second given expression. So question number 1 asks us to find two expressions that sum up to 8x and yield a product of 7x squared. Now if we want two expressions to sum up to 8x, they both have to have an x in them, and just an x. For instance, 5x and 3x add up to 8x, and so on and so forth. But since we also are going to want to look at two expressions that multiply out to 7x squared, let's first look at the factors of 7x squared. So they're all going to have x's, so we can just worry about the coefficient. So let's think of factors of 7. We've got 1 and 7, and that's it, as 7 is a prime number. 1 times 7, so if we have 1x or just x times 7x, we would get 7x squared. So far so good. Now let's check if those two expressions sum up to 8x. So we've got x plus 7x. If we have the same variable and exponents, then we just take the coefficients and do what the sign says to do. So if we have a positive 1 and a positive 7, we add 1 and 7 to get 8. Keep the exponent and the base. We've got 8x. So we found the two expressions that satisfy the problem. Sum up to 8x and yield a product of 7x squared. And this is going to be very useful when we start looking at factoring trinomials when we're not given the middle term as two terms, when we only have, like, let's say, x squared plus 2x plus 1, for instance. Moving on to number 2, now we need to find two expressions that sum up to 15x and yield a product of 36x squared. So again, let's look at factors of 36. Now we've got 1 and 36. If we were to add 1 and 36, we get 37. Not so far. We could do 2 and 18. 2 plus 18 is 20, not 15, so that one's not going to work. Let's say, what about 4 and 9? We've got 4 and 9. They add up to 13, so that one's not working either. And we can do also, let's say, 3 and 12. 3 plus 12, 15. So let's check out 3x and 12x. If we multiply these two together, 3 times 12 is 36. X times x is x squared, 36x squared. Now let's check 3x plus 12x. Same base and exponent, so x and x, we keep our base and exponent. And then we add the coefficients since they're both positive. 3 plus 12, 15. So we found the two expressions that satisfy this problem. If you notice, when we have a positive product and a positive sum, both of our expressions are positive, since we want them to sum up to a positive sum and a positive product. But now look at this case. We have a positive product, but a negative sum. Now if I were to take two positive numbers and multiply them together, I would get another positive number. But two positive numbers do not add up to a negative number. So what we have to do is multiply two negative numbers. Now a negative times a negative is a positive, and when we have two negative exponents, or two negative coefficients, we have two negative coefficients, what we do is we keep the sign, which in our case would be negative, and then we would add the two coefficients together. So for 3x squared, since 3 is a prime number, the only factors of 3 are 1 and itself. So then if we were to pick x and 3x, multiply it together, but again, since we want a negative sum, it has to be negative x, negative 3x. Negative x times negative 3x would give us negative or positive 3x squared. And now we check by saying negative x plus negative 3x. Or we could just write that as negative x minus 3x. Same sign, so we keep the sign. Same exponent and base, so we keep the exponent and base. And then we just add the coefficients together. This has a coefficient of 1, so 1 plus 3 is 4. We've got negative 4x. Again, we found the two expressions that satisfy. So for number 1, our two expressions were x and 7x. And then for number 2, our two expressions were 3x, 12x. And then for number 3, we found the two expressions to be negative x and negative 3x. So far so good. Let's look at number 4. Now we need to find two expressions that sum up to x and yield a product of negative 12x squared. if we're going to want a negative product, we're going to want our two expressions to be different signs. If we have different signs, we're going to end up subtracting those two coefficients, and then keeping the sign of whichever one is larger. So, if we want a positive sum, then our larger expression should be positive. So let's worry about that. So let's think. We've got factors of 12. We've got 1 and 12. Since we're going to have different signs, we're going to subtract them. So 12 minus 1, 11. Not what we want. We've got 2 and 6. 6 minus 2 is 4. Not what we want. And then we've got 3 and 4. 4 minus 3 is 1. Looks like that's what we want. Now we want a negative product, so they're going to be different signs. If we do negative 3x and positive 4x, negative 3 times positive 4 would give us negative 12. X times x gives us x squared. Now if we were to take this and do negative 3x plus 4x, since they're different signs, and we also have the same base and exponent, so we'll keep our base exponent. We'll subtract and then keep the sign of the larger number. In this case, 4 is larger, 4 is positive, so when we subtract 4 minus 3, we get 1, and then we'll get a positive 1, which can just be written as x. So our two expressions in this case were negative 3x and 4x. So again, to emphasize this point, when we have a negative product, our signs are going to be different. And then depending on what our sum is, if we want a positive sum, then our larger expression will be positive. If we want a negative sum, our larger expression will be negative. Looking at number 5, we're going to want to find two expressions that sum to 0 and yield a product of negative 64x squared. Now, if we want two expressions to sum to 0, they're going to have to have different signs. Two positives will add up to a larger positive number, and two negatives will add up to a even smaller negative number. So like negative 3x and negative 4x make negative 7x, and so on and so forth. So what we're going to want them is to have different signs. And they're also going to have to be equal to each other except for the sign. So like, let's say negative 4x and 4x would sum up to 0. So let's think. If we want them to be the same number, we need to think of two numbers that multiply out to 64. In this case, that'll be 8 and 8, different signs, so we need negative 8x and positive 8x. They would multiply out to negative 64x squared. So far so good. We've got negative 8x plus 8x. Since they're the same but differing by signs, they sum up to 0. So if you'll notice, a sum to 0 only works when we've got a negative product, because we're going to need different signs, and if that product is a result of 2 being multiplied, so like 8 squared. But it wouldn't be 8 squared since we have a negative 8 and a positive 8, we'd get negative 64. But they have to be the same number. So it'll be one of your like squares. So like 4, 9, 16, 25, so on and so forth. Now let's look at number 6. We want a sum to negative 20x and yield a product of 300x squared. So we've got a negative sum and a negative product, so they're going to be different signs, and since we have a negative sum, our larger expression is going to be negative. So we've got 1 and 300. Since we have a negative product, we're going to end up subtracting. So 300 minus 1, 299, not 20. Let's try 10 and 30. Notice 2 0, 3 times 1, 300, so we've got the 300. And then 30 minus 10 is 20. Well, there's our 20, but we want it to be negative 20, so we'll have a negative 30x, since that's our larger expression, and a positive 10x. We multiply these out, we get negative 300x squared. And now let's check. 10x minus 30x, different signs, so subtract and keep the sign as a larger number. 30 is larger than 10. 30 minus 10 is 20, so we've got 20. Don't forget your negative. Keep your base and your exponent, negative 20x. So our two expressions are 10x and negative 30x. And for number 5, we said that our two expressions were negative 8x and 8x. And then number 7, sum up to negative x and yield a product of negative 6x squared. So let's think of factors of 6. And again, since it's negative 6x squared, we're going to end up subtracting these. So we've got 1 and 6. 6 minus 1 is 5, not 1, so that's not going to work. Then we've got 2 and 3. And 3 minus 2 is 1, so this is going to be our correct expressions. We've got 2x and 3x. Since we want a negative sum, we want the larger expression to be negative, so we're going to want to be negative 3x. So we've got 2x plus negative 3x, or that can be written as 2x minus 3x. And then different signs, so subtract and keep the sign of the larger number. 3 minus 2, 3 is larger than 2, 3 minus 2 is 1, so we've got negative 1, or just negative x, since we end up keeping our base and our exponent. So the two expressions in this case would be 2x and negative 3x. Hopefully you have a little bit of a better understanding of sums and products, and you'll be able to see in the next video how useful they are for factorization.